right, everyone. Thank you for joining us once again on Did You Know, the ESCO HVAC podcast. So today we're spending some time with Russ King from Kwik Model 3D. Russ, tell me, do you even load calc, bro?
Why, yes, I do. Thank you for asking that.
I do like that slogan.
Yeah, that's a sticker we've been giving away for a long time, and it's very popular. Every trade show I go to, if someone comes up and grabs, I need some more of these. I need some more of these. They put them on their trucks and everything. And the question I always ask them is well, do you?
Yeah, do you? Or do you just want my sticker?
Yeah,
because
exactly.
we got to talk here.
Yes. And a lot of them say, well, we mean to and we want to. And I say, come on, man.
We're going to fix this,
yeah,
right?
You can't harass other people unless you actually do it yourself.
Exactly. Which we have to. We have to fix this in our industry.
Gosh, yes.
Load calculation has always been important. But I feel like as we're making these transitions, especially into inverter heat pumps, right? Mm-hmm. We are doing energy efficiency upgrades. So now we're changing the load of our structure. We're looking at heat pumps as primary heating sources. It's never been as important, I think, as it is right now to load calc on every job.
Absolutely.
Every build.
Yeah. The only exception I might allow somebody is if they're doing like an emergency like replacement.
Oh, yeah. This went down. We got to be up now.
Exactly. Yeah. No problem there. I have no issue with that.
I agree.
But, so many of the jobs that are happening now, they're either putting in bigger or smaller equipment.
Yeah.
They have to justify that. You can't just guess. Yeah. Or if they're going from like a gas furnace to a heat pump, you absolutely have to do that. Heat pumps are... It's imperative that you do a load calc on a heat pump because, if you only got one piece of equipment that has a fixed heating capacity and a fixed cooling capacity, and you have to figure out which one of those you're going to prioritize. Yeah. And you have to know the house in order to do that well. You can't just wing it. Those gas furnaces were a dumb beast. They put out heat and off they go, and then you could pick a different size air conditioner to match your cooling load. Yeah, you just can't do that anymore, and it's really it's a big challenge. But I think it's come a long ways. Since I first started doing load calcs, it would take you a couple hours to go out to a house and sketch it and measure the windows and all that.
Easy.
Oh my gosh, the technology that's out there today. There's LiDAR. There's all kinds of stuff that's just it's taken away all the excuses. It really is.
Yeah, I agree. I don't even know if you know, because we talked about this, it's probably been 2 years ago when I was talking about working on this high performance heat pump book that I was putting together with the Department of Energy. Actually, there's a copy of it over here. There's a section in there where I bring up Kwik Model, right?
Nice. Awesome.
Yeah. And what you do to do things right. Mm-hmm. And it's a requirement. It's not an option when we're doing things right. And when we're doing these high performance upgrades, if you don't have a baseline, you're just throwing darts at a wall, hoping that you pick the right thing.
Yeah, you may have heard me say this before, but I've resorted to shaming contractors. I've tried asking them, I've tried begging them, I've tried bribing them.
I'm going to point you out.
Yes, and now I've resorted to shaming. And what I say when I teach these load calc classes is, you've heard the expression that carpenters use of measure twice, cut once, right? Yeah, well, they're professionals. That's what they have to do. Well, I'm not a professional, so I'll measure once, and I'll end up having to cut twice. I love
chop saws. Right? I can just slide it down and cut off another sliver.
Exactly. And then the short piece of wood goes into the pile for later.
That's a shim for the one I cut too short.
Exactly. But if you don't measure at all, if you're not measuring at all, which is exactly what you're doing if you don't do a load calc, you're not measuring the house. Can you really call yourself a professional, right? Can you? It's just unprofessional to size a piece of equipment to a house without knowing the house, you know. And I think contractors are they're getting away with it too much, and I think it's going to come back and bite us all. Yeah. We talk about the great heat pump revolt of 2027 when everyone's just pissed off and just starts throwing the heat pumps out in the garage in the driveway and wants their furnaces back. You know, that makes us all look bad. And so we really need to nip it in the bud as much as we can. So.
Yeah, I completely agree. I've actually been working on an initiative that hasn't came to the industry yet in full opportunity, but it's very possible. So there's this project called Connected Commissioning that I've been working with on, and it's a lot of manufacturers that are working with organizations like NEEA and looking at ways to verify the actual performance of a heat pump once it's installed. And then in that conversation, we're like, well, hold on a second. part of installation and connected commissioning really has to be, was it sized properly to begin with? Because you will never get the performance out of the system if it's not the right size and right application.
Yes.
It's crucial.
Yes, absolutely. And, you know, and then people say, well, why aren't you talking about ducts? Well,
yeah.
You know, I'm a big fan of baby steps.
Yeah, yeah.
Let's get them to do load calcs, but we can't not talk about ducts. You know, if you put in a heat pump system, one of the main things that affects the performance of the evaporator coil and the whole refrigerant cycle is how much
airflow
and the humidity of the air, and the, you know, the latent removal and all the other stuff. So there's really two big things that need to be talked about. But if we can just get them to do load calcs first, you know, we can deal with the ducts eventually.
Yeah. You know, the worst statement I hear from contractors when we start talking about inverters, but you know, especially inverter heat pumps, is, oh, I like an inverter because I can oversize it and it'll ramp down.
Yes.
And I hear that and I go, no, you're not the right person for this product. You're just not.
A good friend of mine, Adam Muffich, his famous quote,
Adam, very good guy.
His famous quote is that an oversized variable speed equipment is the world's most expensive single speed piece of equipment.
You bet it is.
Because it's always going to run on the bottom. It's always going to run on the low speed. It's crazy.
So let's talk about solutions, right? Let's talk about ways that, all right, now we address a problem. Now we find solutions, and let's give some easy buttons for these.
Yeah. Well, the first one is training. Hit them early, hit them young, you know, get them used to it. I'm probably on at least 10 Facebook groups, and I see these techs making comments about stuff that they really shouldn't be. It's unfortunate. You know, they might be amazing at brazing. They may be awesome at fabricating sheet metal ducts.
Yeah.
But then they make these comments about airflow or sizing equipment. It's like, no, we really, and it makes them look bad because they don't realize that there's other parts of the country that do things differently.
Yeah.
And so they'll see a video of somebody doing something differently. And they go, oh, that's garbage. That's crap. That guy must be a hack. And I was like, that's how they do it in that part of the country.
That works great.
Yeah. So we need to expose students to more variety and get them more used to. One of the big things, and I'm really starting to see it this year at the conference, is instructors walking up to me going, "We've got to get design into our
back into the curriculum,
and it's been missing for so long, you know. And design is a tool. Design, you don't have to design systems to make, you know, to use that skill. It's a tool for diagnosing problems.
You betcha.
And you know, it's a great tool for diagnosing problems. Probably one of the main tools for diagnosing comfort problems in a house. Whereas, you know, everyone's like, oh, well, let's check the charge, you know, let's check the amps and all this other stuff. And it's a design problem. It's oversized, or the ducts are undersized. And they need to understand that. And so, I teach a class at a community college, and it's the division of the college is a construction management program. And so the people in my class, most of them are like future general contractors, future framers, future, you know, those kinds of folks. But it's an introduction to residential HVAC.
To have an idea.
And so we cover, you know, HVAC, and the last 4 classes, I expose them to our software, to Kwik model software. And at the end of that, I say, you know, you guys now know more about HVAC design than 90% of HVAC contractors in the country.
And they're like, wait a minute, but this is an introductory?
Yes. So we really need to get that out there. And I think we've been focusing too much on the hands-on stuff, which is great. And that's my weakness, is the hands-on stuff.
Sure.
But I think we really need to focus more on the theory and the design, you know, why a house is a system. And then probably I think the one thing that is missed the most is that HVAC is a 2-part equation. You've got your capacity of your equipment,
right?
But then the stuff that's missing is the load of the house. You know, look at the house. You can change the performance of the system by changing the house and not even touching the system.
Yes.
So There's a lot to be learned, and I think we're getting there. I think slowly but surely.
We see a lot of initiatives for performance installations, and I'm so excited, right? Because we've had programs, like NCI that has just been preaching, proper procedures forever. And now all of a sudden people are going, hey, did you know that there's things like NCI and there's ESCO, there's like all these things out there that are like helping make, performance like pretty again.
Yep.
And we're like, yeah, everyone's been ringing this bell for a long time. And now it's really needs to be mainstream, right? This needs to be part of our professional development.
Yep.
Understanding that things operated differently 50 years ago. Some things operated very differently 10 years ago. And so understanding the way that we move air and the way that we move heat is becoming much more customizable. And so part of that is understanding how do we actually customize this to work properly, right?
Yes.
And so there's so much in that understanding of, all right, in this structure, where do I need, because we're in the business of moving heat. That's really what we all do. And so when I look at a structure and go, okay, I need to add or I need to remove, where do I need to do that? Are there places that I can improve that? And in that, where did it actually all start from? Because this is not one structure, it's a bunch of small structures within a structure. Right. And without doing an actual load calculation for what those environments, little mini environments need, and then putting them all together and then showing it, well, we don't actually have an understanding of the space that we're trying to condition.
Exactly. Yeah. That's a big thing. And the other thing too to realize is, again, baby steps, focus on doing a load calc and understanding what that means. But when you're doing a load calc, you're really only focusing on 2 hours out of the entire year. It's the 1 hour that it's the summer temperature, and it's the 1 hour that it's the winter temperature. Temperatures change throughout the day, and you need to realize that things go up and down and up and down. And as soon as you think you've got it pinned down, guess what? The temperature is going to change on you, which changes the entire dynamic of the house.
Sure.
But in a way that makes it easier, because one of my sayings is don't waste time splitting hairs when your job is to shave heads. And you just can't focus on little tiny things. And another analogy is it's trying to measure a cloud with a tape measure. How do you measure the length of a cloud with a tape measure? It's a very nebulous thing. It's a very squishy target. And then you throw in the variable of occupant behavior. You can have two identical houses right next to each other with two different families, and they're going to behave very differently.
Absolutely.
And the HVAC system is going to have to compensate for that difference. So I try to tell people, don't stress out on the specifics, on the details. Get it close, understand the bounds of what you're talking about, and just get inside this big circle that you're trying. It's huge buckets that we're trying to land in. It's not these little teeny tiny cups. It's a big bucket. But you got to be in the right bucket. If you're not in the right bucket, you're way off. And so just doing simple load calcs, getting good airflow, it's not that difficult. It's not that difficult. So,
another pet peeve that I've found in the industry, only because I've experienced it myself, is our bulk manufacturing, right? And so during COVID, my wife and I, we bought a pretty nice house. It was very nice for us, 3,200 square feet, brand new construction, reputable builder. And we move into it, and we've got 7 degrees difference between first floor and second floor, summer and winter. I'm going, okay, so who designed? And did you just use this shell design and through your interior walls wherever you wanted it? And maybe you moved a duct, maybe you did not. And it ended up with a poorly operating system. It had been the right calculation, but it wasn't calculated in different sectors at all. It was just a shell calculation. And so as technicians and contractors, we may get called on this call and look at a new construction and go, oh, this should have been designed well. Not realizing that maybe our biggest opportunity we have is to actually relook at this structure to come up with our solution.
Yeah. And the real challenge is, I'm guessing it's a 2-story house.
It's a 2-story.
those ducts go into the first. Where's the equipment? Is in the attic.
Equipment's on the second floor.
Up in the attic, yeah. So you got to get
ducted to the attic.
Yeah,
yes.
so what you're talking about was my world for 15 years.
Right.
I ran 2 mechanical engineering departments that specialized in production homes.
Yeah,
and you can do an amazing design. In fact, the second one that I worked for was a division of a structural engineering firm. And so they would give us the CAD files for the structural engineering that we could overlay our mechanical design to. Even that did not solve all the problems. We still had problems out in the field. And so the whole nature of production homes is, we called it the hair on fire design methodology. Is just like they're trying to cram these projects through so fast, and there's so much coordination that's supposed to happen that doesn't.
Right.
And then they get out into the field and they're just like, well, there's a conflict. We needed an 8-inch duct to go through here, but it won't fit. Let's put a 6, Yeah,
exactly. Ran into that.
Yeah. And then you get your upstairs, downstairs balance issues. But if they would have taken, at least in our case, if they would have taken the engineer's duct layout and they said, okay, let's make sure this duct fits to this room. Yeah. You got to coordinate with their plumbing, got to coordinate with electrical. The framer's going to kill you no matter what. Yeah. And it's a very difficult thing to do. And it's not, the good news is the chances are your equipment is probably oversized. Yeah. And you could actually downsize the equipment, and then your ducts would be more appropriate to the size of the equipment. So there's ways you can fix those things. You can replace the registers on the first floor to get better airflow out of them. Sure. That's just an ongoing problem. Even in the when they spend a lot of money to do a good design, there's no guarantee what's going to get installed.
Exactly. Yeah. And that's kind of the scenario. I look at it as, So I can say that after 23 calls under warranty, a 6-inch duct got replaced with an 8-inch. Yeah, there you go. What a concept. What a concept. Yeah. And so I think you're right, that design is absolutely critical, because that one little change that came off from that design created a lot of havoc. Yeah. And so it probably had a correct design. You're exactly right. In that installation scenario, something may have been changed on that spec model. Wall may have been shifted a little bit. Could have been a plumbing, who knows? But for some reason, an 8 got replaced with a 6 in just the right place. Yeah. And now we're off.
Yeah. Good. That's good.
That's so funny. So it all comes back to right design, right? Yeah. If something is designed properly and the equipment is select to match properly and the ductwork is designed for the capability of it, you can produce a very, very comfortable system that you've used data to arrive with.
You got to have a target to shoot for. You got to know what you're striving for. Yeah. I used to love when the warranty guy from the builder would call me and say, Russ, we got a problem on lot 47. Right. I go, okay, well, what plan is it? Oh, it's a plan 2. And I say, are there any other plan 2s having the same problem? He goes, no, just this one. I go, then it's not a design problem.
No,
is it?
Why don't you hop up there and I'll tell you what's supposed to be there.
Yeah, exactly. And so they would, I always had a sort of a bet with the builders. I'd say, I'll fly down there on our dime, all my time, and if there's a problem, that's a design problem, we will fix it. No questions asked. We'll pay for it, everything. Right. But if it turns out that they didn't follow the plans, or they did something wrong, or the house wasn't built correctly, I'm sending you a bill for my time and my hotel and my meals and everything else.
That'll add up in a hurry.
I never paid for one of those trips. Ever paid for one of those trips. It was always something. Always something. Either they just didn't follow the plans. Right. Back in the early 2000s, when they first started putting low-E windows in all the houses, the low-E window manufacturers couldn't keep up. And so they would just throw a few clear windows in the truck. They go, they'll never know. And so they would install 2 or 3 clear windows in a house that has all low-E. Yeah. And we always said it, invariably it was the baby's room got the clear window, the nursery, and that room wouldn't, especially here in Vegas. I've probably designed 60 subdivisions here in Las Vegas between 1998 and 2005. Yeah. When this area was growing like crazy. Yeah. And so we'd come down here, we had this little thing, it looked like a stud finder. We could put it on the window and press the button. And it would tell us if it was value. But guess what? This is a clear window. Wow. We did our load calcs for low-E, and this is a clear window. So just, all kinds of stuff.
Yeah. Think about how much difference that would have made.
Yeah. Or the another common one, you see a lot of one-story houses where there's like a wing coming off the front of the house. And that's 2 bedrooms. Right. Well, the way they frame the roof, there's what we call California framing on the roof, comes down and the sheathing comes down, and then they build the front off of it. but they have to cut a hole through that sheathing to get to the ceiling. Guess how many times they did not insulate those front 2 bedrooms?
Oh my gosh, because they just seen a solid wall when they were insulating.
Exactly, from the attic. Yeah, just stuff like that. So it's, it's not always, you can have a good design, but if they don't build the house the way you assumed when you did the design, you can still have problems. And so it was always fun to find those kind of things.
I bet it is. Yeah. So let's talk about solutions. Like, what's the easy button?
Oh gosh, yeah. The easy button is again training. I always go back to training. You have to expose the noobs, the new people coming into the industry, that there are these things that they need to know about. And sometimes you can just put it up to them. There's so much information on YouTube and stuff like that. Oh my gosh, I've learned more from YouTube than I learned from college. I swear.
I learned how to build guitars from watching YouTube videos for about a year before I started building my guitar.
I learned how to restore a sailboat.
Exactly. Someone has figured some things out that I don't have to.
Yeah, exactly. Yeah. So I mean, you could learn to do a really good load calc just by watching YouTube, and some of the people that are donating their time, and putting this stuff on YouTube and all these other opportunities. But yeah, learn to do it, practice it. Mm-hmm. For me, the biggest feedback, and it's all about confidence too, right? If you do a design, you want to have confidence in your design. If you're just like, it's like if I did my taxes and I'm not quite sure if my taxes are correct, and you hand those to the IRS, you're like, oh,
I hope it's right, because I don't have any money in the bank if it's not.
Right. But if you're really confident and you say, here's my taxes, I dare you to find something wrong with my taxes. Right. The same thing is with design, and the way you get that confidence is by testing your designs after they've been installed. Oh, yeah. So because you make some assumptions, static pressure, airflow, all these things, throw, noise, all these different things that you assume is going to happen. When you actually go out and you measure that stuff and it's dead on, or even a little bit better than what you assumed, it's like, oh man, you start clicking and you start getting that confidence, and then you start, it just makes you that much better of an HVAC person. You can help other people, you can teach other people. You become a better at diagnosing other problems in homes and stuff like that. So it's good stuff.
Yeah. So tell me how we introduce that in through Kwik model.
Sure. So Kwik model. I used the big 2 out there, Right Soft and Elite. For my entire career, mostly Right Soft. And I taught on it a lot of it. I taught a lot of classes on Right Soft and Elite, and it was very frustrating to me to teach a 3-day class, and then at the end of the class, the contractors would go, Russ, that was a great class, but there's no way in heck I'm going to do this. It's too complicated. It takes so much time. So I've been trying for many, many years. I have a blog article from 2013 that I wrote that said, it's just too complicated. We got to simplify the process. Well, in 2018, 2019, my son graduated from college with a computer science degree, and he wanted to design video games. I said, wait, I got an idea. If you can help me with this idea, I got a project for you. And I wanted him to do a demo for me so that I could show it to some of the big software companies. And the demo turned out so good. I was like,
I think I have something.
Dude, let's run with this.
I don't want to sell this. I think I might keep this thing.
Exactly. So I hijacked my son's career, and he's done a wonderful job. And so we have a design tool that looks like a video game, and we were hoping that would really bring in the younger generation. But if no one's telling them to do it, if no one's forcing them to do it, if it's not being enforced by code, you can't pick it up on your own. Yeah, it's not if you build it, they will come. Right? If you build it, they will come. If you build it and force them to come, then they will come. So, but anyways, it's there, and we the people who use it absolutely love it and just swear by it. It's just getting people to realize it's important, and I think we're finally starting to see a trend where people are like, yeah, I guess I better start doing this, and I think it's been the heat pump. That's been the whole heat pump thing that's been driving a lot of that.
Yeah,
so
it's made people rethink and relook at it, and especially, energy incentives. If you're going to give away money to have a product installed, you better make sure that you're doing it right. You're doing your job, that, you're sizing this thing and then you're laying everything out properly.
Yes, right? Yes, exactly. And so, we're trying really, really hard to keep it as simple as possible. Yeah. My goal is to make our software fun to use.
You bet.
And that's a tall order for, something that's not super exciting. my son's very proud of what he's accomplished. He every single line of code in our software he wrote.
Oh, wow.
My son's a programmer,
right?
And he just thinks it's like the world's most boring video game, but people come up at the shows and tell him what an amazing software it is, and it's good for him to get that feedback too.
Oh, I'm sure it is. So that's it. That whole gamification, right?
It really is. It really is, and the visualization. The 3D aspect. When I show homeowners, we walk through your
house.
Yeah, we walk through their house, and they're like, "This is why there's no air getting in this bedroom, because there's no way to get a duct over there. It's physically impossible." They can't see that unless it's in 3D.
You put it right in front of you, and you take away all of the things that they actually see.
Yeah.
All right, let's get rid of these walls. We can leave the framing so you see where things are, but let's get rid of. Oh, by the way, if we took the ceiling out, we took that insulation out, this is what your house would look like, and these are the obstacles that everyone has had to work with during this process.
Yep, exactly.
Very cool. So tell us, where can we learn more about Kwik Model?
Sure, just go to our website. It's spelled KWIK model. Kwik Model. Go to YouTube, just search for Kwik Model.
Good stuff out there.
But our website is www.kwikmodel.com.
Okay.
That's simple, yep.
Fantastic. I appreciate your time today.
Oh, it's great to be here. It's always fun to do these with you. It's a blast.
All right. Everyone have a great day.